Hello and welcome everyone. We're excited to have you all attending today's webinar. I'm Jim Olson, the Assistant Executive Director for the National Tile Contractors Association, and I hope you and all of your families are healthy and safe. Today's webinar is titled Going Curbless. We will tap into a growing design trend and offer something that will delight your customers. This training focuses on the techniques needed to build reliable curbless showers that are in high demand. Specifically, we'll examine multiple approaches for achieving zero entry showers using the latest industry technology. Our sponsor and presenters for this program is Schluter Systems. Please look for their advertisements in Tile Letter magazine and multiple NTCA digital platforms. Before we continue, I have some business to take care of. Today's webinar will be muted. Please use the questions area on your computer to type in your questions. We will answer your questions at the end of the presentation. All of our webinars are available to watch at any time on the NTCA YouTube channel within 48 to 72 hours after the webinars are presented. Please go to the NTCA YouTube channel, subscribe, and you'll be notified of all upcoming NTCA videos, including all technical webinars, giving you easier access to watch all current and past programs at your convenience. If the audio on your computer is poor, call the number provided on your invitation and you can listen to us on the phone. Today's speaker, Andy Acker, is responsible for the Schluter Systems Education Program and acts lead presenter for the Innovation Workshop Series. His focus is developing education and training classes that provide the tiling community with access to industry-approved installation methods and an understanding of how Schluter products can increase the durability of these installations. Before joining the company in 1997, Andrew was a tile installer for 20 years, with over half his experience as a California State C54 licensed tile contractor. Andrew also serves on the board of directors of the Ceramic Tile Education Foundation, and we're lucky to have him here. Welcome, Andy. Appreciate it.
Thanks, Jim. Appreciate the invite from the NTCA to come and give one of these seminars that you do throughout the year. So happy to be here. I also want to extend a welcome to all of you folks that are tuning in right now. I appreciate your time. Your time is valuable. It seems like a lot of us have even sped up during this COVID-19 era. So again, it's nice to have you on board. You can see from the screen here that we are going to look at these zero entry showers, going curbless. And we'll look at a couple of different things here. We'll look at the design trends that are current, because this is a big hot item right now in the design that the consumer really likes. And we can take advantage of that. There's some different materials that you should be looking at when you go to build one of these curbless showers, and we'll get into the reasons why we're looking at particular materials and typical applications. Also, the methods for building. There's an opportunity here, if you can, to alter some things to make this as seamless as possible. Other times it can kind of be done retrofit. So we're going to look at all those different aspects here. So the design trends and advantages of going curbless. Well, open concept design is very, very popular these days, not only in the main living space, but right into the bathroom now. You can see the example up on the screen there. There is no curb, there's no door. This is just simply a splash guard. You can see some other design elements that they put into place here too that we'll note also. So open design is one of them. How about the large porcelain panels that are really gaining traction in our industry, getting very popular, less grout lines. They really do a good job of replicating natural stones, for instance, but are getting very popular out there. So that's another thing that we're looking at, is large panels, which means a lot of time we don't want to switch to a small format tile as we go into the wet area. We want that continuous look that goes right into the shower area. We'll take a look at that too. Again, natural materials. Look at this. It looks like wood, even though it is a porcelain. Many of you are familiar with this type of tile out there. This is another very strong trend that's going in here. And you can see here this wood plank look is in the bathroom and continues right in to the shower floor and then goes up the back wall as an accent there too. So why go curbless? Well, you can really change things around. A lot of consumers are wanting this thing for the design element. It's not necessarily a necessity yet, an aging in place issue yet, but maybe they're looking at the future, or maybe they just like this design. So yes, we're used to showers and we can make showers look very attractive, but you can see that there is a nice added design element if you do the curbless showers there. Also, you can make a space that seemed kind of cramped with the door and with the curb and even maybe some return walls and a soffit. You open that all up, you do one tile that's continuous right in there, and it makes it seem larger, even with some of the limited spaces that we could have. Now, a lot of people go, wow, this is going to cost a whole lot more money to actually do these type of curbless, and that's not necessarily the case. You know, when you think about all of the different materials that are used and the extra labor to construct something like you see on the left side, you can see that you can actually, it's not that much more expensive, and sometimes it isn't any more expensive at all. And we'll look at a couple of options here to actually do these things, so they can be very cost effective. So another reason could be the accessibility. Certainly a curb is a barrier to some people that need more access than a curb allows. So that could be there for barrier free, or it could just be simply curbless. You take the picture on the right, if there wasn't a wheelchair in that photograph, you probably wouldn't even consider that to be a ADA or handicapped, as we used to call it, although that term is kind of worn out these days. You wouldn't consider that to be that kind of design, but when you take a look at it, it does have all the elements that you would actually need to make this a barrier free. And we'll take a look at what the differences are. Also, you know, we want to have flush transitions. So in many cases where we've had to build the floor up so much in order to have a higher elevation so we could get a slope down to the drain, that doesn't necessarily have to be the case, because we're actually changing the substrates and the way we're going about preparing and building in a slope to the drain. And we'll see this. So we definitely want the flush transition. So keep that in mind. So what is the technology that makes curbless possible? You know, this has been around for quite some time, but they were very time consuming and costly to do before some of this new technology that came out. And what that new technology is about is actually moving the waterproofing up on top. So before we jump in, let's make certain that we're talking about the right thing. The title of this presentation was Going Curbless. That simply means we're going to eliminate the curb. The other thing we would be using, and I used this term just a couple of minutes ago, is barrier free. Now, barrier free means a totally different thing. So don't confuse them, and don't talk about barrier free unless you're going to add all of those other design elements that are required in order for you to use that term barrier free. Barrier free means there's no barrier to anybody of any ability, disability, or age to use the facility. That means if you look at the little inset picture there, it has things to do with where the grab bar is and where the bench is and what are the dimensions of the bench and what are the dimensions of the shower area itself and where are the niches and the shelves. And there's a lot of stuff that comes into barrier free. So these components that we'll look at today can certainly be applied to barrier free, but we're not incorporating all the other design elements. We're just simply looking at eliminating the curb to give you that zero entry. So keep that in mind. So the key differences are curbless, we're taking out the curb. If it's a barrier free, look at the whole list of things that you really have to comply with when you actually use that term barrier free. So keep that in mind. Don't get yourself in trouble. I used to tell tile setters back in the day, don't say you're going to make the floor level unless you truly mean level. What you really mean is flat. So there's a difference between flat and level, isn't there? Same thing here. There's a difference between curbless or the term barrier free. Now, if you do want to go barrier free, certainly, as I said, many of the components that we're going to look at today are used for barrier free also. And if you do want to actually put one of those in, There's a lot of guidance out there in the industry, so keep that in mind. There's the Architecture Barriers Act, and there's the Uniform Federal Accessibility Standards, and of course, most of you are familiar with the ADA, the American Disability Act. The newest one out there is the 2010. There's a lot of guidance in there on how to actually build a barrier-free if you wanted to do that. And then, of course, our very own Tile Council of North America has some standards, has some guidelines in there too. So, curbless versus curb. You can see the difference here. The curb is going to be your barrier. We're just showing it on one side there, so you kind of get a cutaway view into the actual area there, into that environment. And then with the curbless, you can see you're going to be able to run right in there. So there's also two differences here, is where what kind of drain we have and where it's placed. So there's lots of options here, and we're going to take a look at the different options there. So one of the things that allows us to actually do these type of showers now a lot more cost effective and a lot more efficient is that we now have surface waterproofing. Now these waterproofings can come in a sheet. They can come as a liquid that's rolled on like with a paint roller or a brush, and trowel-ons that are thicker that you put on with a notch trowel of a certain size, and then you knock the ribs down to create a certain thickness of membrane. So there's different ways to use surface waterproofings. There's quite a few of them on the market. You'd want to actually do your homework on that and research which one is going to be most effective for you and your application. But this is a big issue on why we're able to do these, because in the old days, the pan liner, the waterproofing was underneath a substantial thickness of mortar bed, which means we had to either recess the floor quite a bit in order to make room for the slope to the drain and keep our zero entry as we moved in from the bathroom into the shower, or we had to build the whole bathroom floor up substantially in order to get the slope down. Now these days, we're basically doing bonded membranes that we bond tile directly over the top. So that's one of the big technological advancements that allows us to look and do these things, again, a lot more costly, a lot more efficiently too. So you can see here in the image that we just basically come in straight off of the bathroom. This particular one here shows a recess of a tray that's got a slope to it that slopes all the way to the back wall, and then provide the drainage at the very back wall. And we'll take a look at some of these trays. They're out there from various manufacturers, various dimensions, drain placements, and thicknesses around their perimeter. So we'll look at that. In the Tile Council of North America, you'll find that this is an old image. It says -15, but that was from the 2015 image, but it hasn't changed a bit in the current issue. It's still 422C. You'll look at that. You can see another element that really made these waterproofings effective, all these surface waterproofings that I talked about, is the incorporation of an integrated bonding flange. Now that we have that component, we now have a drain that's designed to accommodate surface waterproofing at the surface. All the drains that were afforded to us from the plumbing industry before an integrated bonding flange was developed were designed to accommodate the waterproofing, the pan liner, underneath the mud bed. So that made for the thick assembly. Now we simply move the drain up on top of the nice wide bonding flange to accommodate the waterproofing directly to it. And now we can make much thinner assemblies. Here's another detail showing that, a stylized drawing on the left, and then again, the actual assembly drawing there on the right-hand side of your screen, showing the integrated bonding flange and how it's up on top of the mud bed, or in the case that we're going to look here, it could be a mud bed, a mortar bed, which is just sand and cement packed in and screeded off to create the slope and support the tile under load, or it could be one of the pre-manufactured, mostly foam core type of shower trays or shower pans that have the slope built into them right away. So there's a couple of different ways to do that. Here's a better picture here showing 422C, where you can clearly see the integrated bonding flange is up on top, flush with the surface of the floor, and the waterproofing is tied right in around that flange around there, and the drain grate goes right in flush with the tile. So it's a much, much thinner assembly. That's one of the key elements here. You can use, as I said, point drains where the water slopes to the drain from all around the edges of the drain with a different location for the drain. It doesn't have to be right in the center, but nonetheless, your perimeter is all even and level, and then it slopes down to the drain. The other one that's gotten very popular because of the large format tile and the requirement to bring that same size tile right into the shower is the linear drains. Many of them on the market, several different manufacturers have not only the drains, but the trays that are a one flat plane that slopes down towards the drain, so you're not limited to what size tile you can put on these. The picture on the left, you can see we probably have, it looks like a 1x1 tile on that. That's drawing there. You can go up to maybe a 3 or 4 inch square tile, but after you get larger than that, it's hard for the tile to conform to the compound slope that's required in these trays when they slope. So that's one of the reasons why the linear drains have become so popular, because they do accommodate the larger tile. Now, here's a little bit of that look of that traditional construction. This is one of the issues that we have with building curbless, is that these type of membranes, if you will, you're basically creating a bladder that's going to hold water and the mortar bed inside of this bladder for the life of the shower. So there's really a couple of problems here, which is how do you continue this waterproofing outside onto the general bathroom floor when there's no curb or no door, and there's no way to tie this waterproofing together? Matter of fact, the Tile Council of America gives us no guidance. So you're kind of on your own to try to figure out how to tie in the waterproofing that was in traditionally the wet area, the shower, into the area that was traditionally the dry area, the rest of the bathroom, when there's no curb or door any longer. You're really going to have to take into consideration that you should be carrying the waterproofing further out and covering most of the floor in the bathroom, if not the whole floor there too. So here's another image of that being tried to be achieved, and we're not quite certain how they're going to tie in the waterproofing once they get outside that shower area. That is going to be, again, something that you're going to have to try to figure out with not a lot of guidance from the tile industry. So that's where something like uncoupling membranes that have gotten very standardized, very common in the industry, which is the underlayment that you'll bond the tile to, and most of them that are on the market are waterproof in themselves. So if you're actually putting this uncoupling membrane on the general bathroom area, you can just tie this in with the surface waterproofing in the shower, and you get a completely waterproof environment there. You know, back in the old days, you see the pictures across the bottom. This kind of shows you the sequence of events in the tile industry and how tile installation has changed through the ages there, where you go with the old assemblies. The first two that you see are relatively thick, and certainly compared to the last one on the right-hand side of your screen, which is a direct bond system, that's what we're looking at. We're looking at introducing an uncoupling membrane, which means the tile is going to be protected from the dimensional changes of the substrate it's typically bonded right to, but also we can protect the substrate from ever getting wet or being damaged by water by introducing these membranes, because as I said, most of them are waterproof in themselves. So you can see how you can tie these things together from one course to the next. And then in the upper right-hand corner, you can see here you can get that shower entry. It's seamless there between waterproofing on the main floor and the waterproofing in the shower, carried right through. Nice, easy way to do it. And you can ensure that you're going to have waterproofing not only in the traditional wet area, but out in what was traditionally the dry area. But now we should really be treating it as the wet area also, since we did eliminate the curb and the door. Here's another great photograph showing this. Now, a couple of things to make mention here. You should take notice of. Here you can see that the wet area has been treated with a sheet membrane, a waterproof membrane that goes right down and ties in to the drain flange. And you can see that this is going to be a long line drain there that's placed underneath the niche on the wall, and the mixer valve just above it. So they're going to have a very long line drain here, tied all together, so it's all waterproof there. and then they've brought the waterproofing membrane right out onto the uncoupling membrane, which is waterproof in itself. And you can see that the seams of that membrane are treated, and all the way around the perimeter of the walls. So now you basically turn the entire bathroom into a shower pan in essence. Now here it is finished. This is a finished shot of the picture you just looked at earlier. Here's the after, and here's the during, not the before, but during construction here. And here's the after picture. You can still see the niche and the mixer valve. If you look closely, it's hard to see, and this is a reason why a lot of consumers like this. It's hard to see that the line drain is placed there right at the wall underneath the niche. And then we've got large format tile that we're able to carry right into this wet area because it is a flat plane just sloping back towards the drain, as I mentioned earlier. So there's really three ways that we're going to look at right now on how to achieve these here. Let's look at these most common building methods to achieve this curbless. Now, in this photograph you're looking at, it, if you look through the title band there, you can see that they've actually removed the subfloor. So that's one of the ways we're going to look at it. But basically, there's three ways to do it. You can raise the substrate, which means you can take one of these trays, these shower pans that are pre-molded, and you can place them right on top of the existing substrate. Maybe this is going to be the most economical and time saving for you, the most efficient. Maybe you have a concrete slab that's actually a structural slab. It's post-tension or pre-stressed concrete where you can't be cutting into it. You can't remove it because it's a structural element. This is going to be one of the options for you, is to place the tray right on top of the floor. And these trays are fairly thin, actually. And then you actually put a ramp. Now, the ramp does meet Americans with Disability Act slope ratio, so you're safe there, even if you want to make this a barrier-free. But it does make for a nice even ramp as you go into the shower. So again, these are for quick retrofit, economical, or maybe because of structural elements, you just can't go by recessing the floor. This is one way to do it here. The other way we're going to look at is to raise the entire bathroom floor. And you're like, oh, yikes, you were just talking about that, Andy. We don't want to add a lot of height because we still need to have access into the bathroom from an adjacent floor, and we just don't want to move the curb over there or have too high of a ramp. We'll take a look at that. You can see how thin these are, and there could be a couple of possibilities there. And the third one, we're showing here in a wood frame over joists to recess the substrate. So you could do that there, but you can't do that on concrete that isn't structural, but this is really a popular option. So let's take a look here. So here's the prefab shower tray. This happens to be a 6-foot square shower tray that has the membrane already applied to the foam. The slope's all built in. The perimeter is all dead level all the way around there, if the floor was, that they put it on. And you can see the ramps just abut to the front of the tray, and now you have your access straight in there. So that is one possibility. Here's the picture of it after it got tiled, and it's showing you with the dash line where the ramp actually is in relation to the floor tile and the actual shower pan inside. So keep that in mind, and that could be an option there. Now, the prefab trays, as I said, several different manufacturers on the market right now are offering these of different shapes, different sizes, different drain locations. So see which one is most suitable for you. I can tell you, you don't have to use these exactly at the dimension they're showing or that they come. You can cut them down, or you can add on to them too with either panels that have a slope or create a slope with the panel, or you can use your standard sand and cement mortar bed to add on to carry them out if they're not quite the same dimension as your area that you're going to put one in. So keep that in mind. They are adaptable a bit. So these are some of the thin trays that are on the market, and you can see depending on where the drain is, you keep rising as you move away from the drain, don't you, to create slope for the water. So some of them are as thin as 7/8 of an inch. A couple of them where the drain is way over to the edge, you'll find that they climb up to 1 1/8 inches tall. So keep that in mind too. So here's one of the thin ones out there. This is a great one for a curbless, and what I'm showing here is where we're putting the tray directly on the floor. We weren't able to recess the floor, the substrate, whether it was concrete or wood. We're setting the tray on top, but instead of using a ramp, we're adding 3/4 of an inch of plywood or OSB, your panel, to the entire rest of the floor, and then putting the uncoupling membrane on top of that, and now we have a flush transition. This, of course, is done before the waterproofing with the banding and so forth that we looked in the earlier pictures. But you can see this is only adding 7/8 of an inch to the floor. So in many cases, if you actually have an adjacent room that has carpet and pad, you'll find that in many cases you could make this almost a flush transition. So keep that in mind. And even at the ADA, you really don't have to have anything more than a ramp transition until you are above a 1/2 of an inch in elevation height from one flooring to the other. So keep that in mind. So this might do for many of you by just adding the extra thickness on the subfloor. So you can add different thicknesses of extra panel, depending on what your tray size is. But in this instance, we're showing a 7/8 inch thin tray with the 3/4 plus the 1/8 of an inch, and you are now flush on that transition. So this is how it would actually look with the rest of the membrane down, the tray in place, and you can see some of the waterproofings have been started on the walls, but now they'll finish the waterproofing by tying in the walls to the tray and the membrane, the uncoupling membrane to the tray, and then they'll have it all watertight and ready to go. And we only raised the floor 7/8 of an inch here. So there's the continuous waterproofing all in place. So now we have a completely sealed up system ready for tile and ready for use. Now, nobody really wants these type of things, so you try to keep these at a minimum. Here, they actually had hardwood outside. Most of the hardwood that you're going to encounter on the job site now is about 3/4 of an inch thick, unless it's pre-finished, and then it'll be about half that thickness. That's not going to do you a lot of good. But the traditional 3/4 inch thick hardwood with that 7/8, you can see you're only 1/8 of an inch short, and then you put your tile on there. You could be less than that 1/2 inch of transition between the hardwood in the adjacent room and the tile in the bathroom. So these curbs here are the sill that you're looking at. The marble sill is one way that you could do that. That's about 1 inch thick. And then the wood transition is a big one there where it's still fairly thick, even at the wood end. And it's hard for you to see from this vantage point, but that is ramping up. So that was actually quite a bit of buildup they did there. We want to try to eliminate that as much as possible. So this turns out to be one of the most popular types here, where you actually remove the subfloor that's sitting on top of the joists, and you actually block out and actually sister on side of the joist, the existing joist, without cutting them. You don't cut into the joist because we could change things structurally, and if you're not an engineer, I wouldn't be going around chopping the joists down as far as how thick they are, because they're engineered to span certain distances and carry a certain amount of load. And you start shortening them by chopping them out, you better have an engineer make sure you're okay. This doesn't do this. You can see that we've blocked out and we've ledgered on the sides of the existing joist down the same thickness as the subfloor panel. In many cases 3/4 of an inch. So now the subfloor panel doesn't sit on top of the joist any longer. It actually sits between the joists. So you've gained that full 3/4 of an inch right off the get-go. So that's something to take in consideration here. You can see here's your recess shower area is going to go in here. You've got the original joist, and you can see the riser pipe coming up. Now we put the ledgers on each side of the joist, and then the actual subfloor panel now goes back on that surface. So you can see it drops it from the original elevation down the same thickness as the subfloor, and you've gained quite a bit of your space. That's going to accommodate most of your tray. You put the bonding flange in, and then when you put the uncoupling membrane on the outside, which are 1/8 of an inch to some of them are maybe even 1/4 inch thick, depending on which one. Now you've got a flush detail showing going right into the shower area. So, and then you put the waterproofing on there to tie it all together like we saw. Here's another photograph kind of tying in, getting in closer to it. You can see how it's recessed in between the joists to create that extra recess there. And you haven't changed anything structurally. So that's really a very popular one to do. A little more time consuming than the other. So you can see from the three we looked at, it depends on what your current situation is, what's the budgetary constraints, if any, on the job site, and what kind of structure do you have. So a lot of things that could take into consideration on which one you end up choosing. I can tell you that in many cases where I've gone in to retrofit a home where suddenly someone was in a wheelchair and had limited abilities for maneuvering around, a lot of time what we would do, we wouldn't actually retrofit the existing bathroom. We'd leave that alone. We'd take another small area and put a shower in. And I did many of these with putting the tray on top of the existing subfloor, putting the ramps up to the front of it, using the uncoupling membrane on the rest of the floor, tying it all together and waterproofing it. And I was completely prepped and ready to tile in about a half a day for some of these showers. And most of them were about a half a day prep. And then we were ready for tile and totally waterproof, and we could accommodate somebody with a disability. So keep that in mind. So the pros of the first one, where it sits on top, it is going to be the quickest and the simplest and probably the cheapest as far as labor that you would have to pay for. But then you don't have a flush transition at the shower entrance, but then you haven't built it up over the entire bathroom floor, which is what you've done with the second one. Now you have a flush transition at the shower entrance, but now you've got the elevation that you added to the whole rest of the bathroom. So keep that in mind. And then the third one, recessed over the floor joist. There, of course, that's a flush transition into the bathroom and a flush transition into the shower area. It may require a structural engineer, but for the detail that I showed you there was no engineer involved because we didn't alter the structural joists. We didn't cut down the height, so we don't have to worry about load bearing capabilities being altered or span capabilities being altered. But there is a little more complexity that you can certainly see that as we went through those. Now, you can certainly recess over concrete, as I mentioned earlier. Sometimes that is an option to actually remove a certain percentage, a certain thickness of the concrete, and then smooth it out and put the tray in its place. Other times I've seen general contractors remove all the concrete when it's a slab on grade or below grade, and then re-pour the concrete inside minus the thickness of the tray they're planning on putting in. So you can do these over joists. We didn't really show that today, but yes, that's another way that you could recess in there. Just a couple other things that this usually brings to mind. Now, since you've taken the curb out, and many times you have no door, there might be a splash guard, there may not, but you might need to keep some of the water back in there. Where this one is the most important is if you've moved the drain closer to the front of the shower. Like if you put a line drain across the front of the entrance of the shower, what that allows you to do is keep the low elevation throughout the entire bathroom, and the only slope in the whole shower is going away from the drain up into the shower area. So you're actually intercepting the water as it's running towards out of the shower, but it's not getting out of there because you've put the line drain across the entrance. These are going to be really quite helpful. And you can see you can put them in while you tile, but if you did put one in and now you've got water that's escaping around the edge of the drain or coming across on the soap suds, then you can see you can retrofit it too. So the one on top, that's the elliptical, that actually meets the ADA requirements. Unfortunately, the one on the bottom, although collapsible and it'll spring back up if someone wheels across it, it's still too high of an abrupt vertical in order to meet ADA. If you read the strictest sense of the ADA guidelines, it can't be that tall. So keep that in mind. But both of these would be a great a solution if you have any water trying to escape out onto the bathroom floor. Some places you might even be required to put in a secondary drain to catch any water that might escape. Certainly this is something that you find in public use areas more often than private residences, but you can see a secondary drain has been put in here. And this one is just simply with a piece of the same tile that's on the floor is put in that place, so you hardly see it at all. You can see here they've actually kind of hid it underneath the vanity a little bit. So keep that in mind. Check with your municipality on requirement if you need secondary drainage. The third thing that comes up quite often is an inspector will come out and go, I need that thing flood tested. And you may ask, well, how am I supposed to flood test a curbless shower now? Well, you actually have to in some cases. A lot of places say, no, you have enough slope ratio between your existing floor and where the drain grate's going to be, that as long as you can fill up to there, you'll be okay. Other inspectors, again, open to interpretation from county to county, city to city, state to state, province, it doesn't matter. They might want to have a vertical flooding too. So we're showing you here how you can actually create a temporary curb in order to do the flood testing. So it's not that difficult. It's not that time consuming. You can see you just put in some framework, support it with some boxes of tile you have on the job site anyway. Use some of the banding to actually do the floor to wall or flat to vertical transitions. Let it cure up overnight, and then you're ready to do the flood test. And you can pour a lot of water in those, just like if it was a traditional curb shower. So keep that in mind, that may be something that you may need to do. Sometimes I've heard of it being done. So keep that in mind. All right. So the key takeaways here from this real brief presentation was that there are trends out there. And of course, the design elements are something the consumer is looking for. And these days, it's a lot easier to tell them yes, because not only do they get the design they want, but you get the function that you need too, as the one who's actually going to build it or specify it or design it. So it's going to hard to be doing continuous waterproofing when you're using the old pan liner type of systems. It's kind of difficult, and there's not a lot of direction from the industry on how to do those particular ones. The sheet applied and the uncoupling membranes together actually make it very simple and very quick, and take a lot of the dangers inherent with the traditional systems out of play when you use these type of systems. And we looked at the most three common approaches: putting the extra components directly on top of the existing substrate with a ramp, or accommodating extra thickness by abutting another elevation change to the whole bathroom, or by doing the recessed floor. So those are really the three most common options that are looked at out there on the market. All right, so that's the end of this part of the presentation. I do want to thank you for your attention right now. I'll hand it back to Jim to see if we have any response at this point.
Andy, thanks for your brief and knowledgeable, presentation. That was great. I'm sure our audience appreciates the expertise on this topic, and it was extremely informative. Thank you. Good job. We do have a few questions here, and I think you did such a good job that there won't even be that many questions, but maybe more will come in. So one of our attendees said their subfloor is constructed of 3/4 inch planks for the wet area. He wanted to know, do you cut it out and put in 3/4 inch plywood for the dry area? His plan was to use Dietrich heat. Do you have to build on top of the planks? He said he read that he needs a total thickness of 1 1/4 inch for stone tile.
Okay, that was 3 parts, wasn't it, Jim?
Yeah, that was a lot. That was a lot.
That's okay. We can address each one of the, I see 3 items that we need to address. One, yes, I would get rid of that plank where you're going to recess the floor and replace it with a plywood or an OSB. That's going to be the easy part there. Yes. The second one is when this caller or the viewer is talking about plank, they're talking about a structural plank. In other words, the home was built before plywood, which means it's probably pre-World War II, because plywood was really a byproduct of World War II. And then the building industry caught on and started using it for residential. But prior to that, you'd actually use a plank flooring. It could be 1 by 4, 1 inch thick, or 3/4 of an inch thick by 4 inches wide, clear up to 2 inches by 12 inches wide. It's all considered structural plank by the tile industry. And everyone in the tile industry understands that that's not a suitable substrate for even ceramic tile, let alone stone, which was mentioned also. So all underlayment manufacturers in the tile industry require a minimum thickness of 1/2 inch of plywood or OSB played over the top of the existing plank, and then you're ready for tile. And now in this case, since you have the structural plank and your 1/2 inch, all fastened together suitably, now you are actually going to meet the requirements for natural stone. Now, to say 1.25 inches is mandatory, that's kind of an easy way out of really the real explanation for the natural stone needing a beefier floor. It really has to do with natural stone having much lower flexural strengths. How much it can bend and deflect without rupture has a much lower flexural strength than ceramic and porcelain tile. So therefore, you needed a stiffer floor for any type of natural stone, whether it's a wet area like we're discussing here, whether you have structural plank or you have plywood or OSB, you're always going to have about 3/4 and another 3/8, or if you have 5/8 subfloor to start with, another 1/2 inch. So yeah, you're getting to about 1.25 inches. That's going to give the floor the stiffness that's required for natural stone. So how did I do, Jim? I think I hit all 3 of the points from that.
You did good. So we handled the Dietrich heat.
Oh, yeah. And the Dietrich heat, of course, is suitable right in there. Now, if he wants to bring the Dietrich heat right into the shower, which many people do since there's no curb, why not? Why not just run the heat right in there? You could certainly do that. Our particular product made by our manufacturer that he mentioned, Dietrich heat, is a membrane that accommodates electric wire in-floor heating. There are other manufacturers on the market that have the same technology, the same systems, but nonetheless, they can run, ours can run, and I'm fairly familiar with some of the other manufacturers. I believe most of theirs can run right into the wet area, but they're still required that you create a continuous waterproof envelope all through the whole shower after you put that in. So what you do is you'd run that membrane on your entire bathroom floor, right down into your shower area, and you'd raise your integrated bonding flange again up because you want it flush, and then you'd actually you'd put your cable in, and you'd fill all that void and encase that cable into the membrane that's holding the cable, and then you'd put another layer of waterproofing, whether it's sheet applied, trowel applied, or roller applied. You'd put another coat or a layer, a sheet of the membrane on top of that to create that continuous waterproof envelope. But yes, you can run the heat right into the shower. Now, I might as well bring this up. I feel like I'll do you a disservice if I don't mention this. You will find in the electrical codes that you can repair in-floor heating cable, electric cable. But in a wet area, you cannot. It's not from the manufacturers of the cable or the heating systems. It's from the electrical code. You cannot repair a cable that's had damage to it in a wet area. So if you are going to run cable into a shower, this has to do with whether you have a curb or not, but in this case we don't. You should actually run a smaller little kit that's just going to cover the shower floor, and then use another kit for the rest of the bathroom floor. You can still control both of them based on size. You can't get too big, over 200 square feet, but you can still control both of those cables with the same thermostat. So you're not doing anything extra there. You're running them both to the same thermostat, hooking them up. But here's the bright side of this. If that cable ever gets damaged in there, yes, you'll have to abandon it in the shower, but you won't have to abandon the rest of the cable out in the bathroom floor. And I also find I have heating cable in my bathroom right here in my home in Kansas City, Missouri. And I can tell you that I actually found that the hot water from the shower warms up the tile in the shower area so fast that I'm really not benefiting anything from putting the cable right into the shower floor. So just food to think about there.
Good job, good answer. If the Dietrich's waterproof, then why not carry it through the shower floor?
Well, you could, but keep in mind that our integrated bonding flange is designed to work with a thinner membrane. So as I told the earlier listener, the earlier questioner, you just have to bring the integrated bonding flange up just a little bit more so that it would flush out with the top of the uncoupling membrane instead of where it typically resides, which is in a little recess in the tray that accommodates the thickness of the actual drain flange around there. So sure, you could do that if you wanted to.
Okay. I'm not sure I quite understand this, so I'm going to read it to you, and maybe you'll understand it. I have a 32-inch by 60-inch shower space. Should I add to a 32 by 48 or trim down to a 38 by 60?
I'd get the one that's closest to the size that you're going to use, and I'll tell you why. All of our trays have a slope ratio. They slope 2%. That's code. 1/4 inch per foot, you could say. But as they move away from the drain, they continue to rise. So if you're cutting off substantial amount of foam, you're actually decreasing the thickness and the height of that tray at its perimeter. So pick from the shower tray that's closest to the size that you're going to be putting that in so that you alter it the smallest amount of height. In the case of that, you're not going to be cutting much off the edge. It's hardly going to be an elevation change at all in that particular instance. So I would go with, in this instance and any instance, I would go with the tray that's as closest to the dimensions of the size you're going to end up with.
So
I did follow that, Jim. I did understand what you were talking about.
Yeah, I think what you're saying then, he's better off if it's a 32 by 60 area to use the 38 by 60 and cut that down than he is
Right.
to try and use,
Right. Put 32 to 38 is 6 inches, right?
Right.
So he's only going to take 3 inches off each side.
Right.
So in 3 inches, if you think about 1/4 of an inch of rise in 1 foot, and he's only going to take 3 inches off of that, that's 1/4 of an inch. Right. So it's only a tiny little bit of rise that he's going to be eliminating, not enough to cause any problem.
That's the way he should go. Is I guess I just wanted to completely answer that question. Good.
Okay. Sure. Yeah. And for any other viewers that are listening and thinking about their own, I think that since they could have specific measurements that we don't, we're not going to discuss here today, the rule of thumb would be pick the tray that's closest to the size that you're going to have, where you cut off the minimum amount or add the minimum amount. That would be the best way to go.
Right. All right. I have a 3/4 inch thick stone shower floor with machine slope to drain. Can I set or adhere this directly to uncoupling membrane like a giant 36 by 60 large format tile?
Well, you can, but it's always important to have a slope to the substrate before you apply your tile. There is a chance with a natural stone, mostly, of some water making its way through that stone. And when it hits that membrane, the water's going to stop. It's not going to be able to do any damage anywhere below, but there's nothing there to get that water to make its way to the drain. But for most of the part, yes, you're going to be okay. I know what they're talking about. We've seen quite a few of these machine stone single piece trays. They're beautiful. There's no doubt about it, but they do require waterproofing, and Curdy would be your waterproofing, sure.
All right. And I have to apologize if I'm reading these incorrectly. Not always typed questions come out the same way they're meant to. So the next one is, I have a shower and it has it's concrete. It has 8-inch thick wall that is adjacent to their neighbors. Is it possible to use the waterproofing membrane and then tile it directly without using Curdy board?
Absolutely. Yes.
It is. Oh, okay.
Mm-hmm. Yeah, we can go over most of the membranes that are on the market, and certainly the ones from the manufacturer I work for are actually designed to go over various types of substrates. Concrete block masonry unit, like in this particular instance, you're ready to go. Now, check for potential bond breakers, paint, epoxy paints, anything peeling, potential bond breakers of sealants or anything like that. But for the most part, yeah, you're ready to go. Various manufacturers have a list of the various substrates that are suitable for their particular membrane. So check with that. But I can answer ours, certainly, that yeah, ours can go directly on that.
Yeah, always check with your manufacturer on those questions.
It supersedes anything, right, Jim?
Yep, supersedes everything. Yep, manufacturer's recommendations are definitely the way to go. So the next one is a curbless option is possible at an outdoor shower, and it's popular. What would be the challenges to look for when having to waterproof an outdoor space for a shower?
Well, I've done quite a few of these where the concrete contractor actually floated the slope to a drain, right out in the open. You know, a lot of time a cabana club, a pool facility or something like this. The problem was to get a watertight connection to the drain. Usually the drains were in. They were already, you know, floated flush. The concrete was flush right to the drain grate. There's no flange. There's no way to tie that in. There are a couple manufacturers that make little retrofit kits to raise the grate up so the grate can be flush once you tile it, but that does nothing to help you tie the waterproofing in there. But let's be honest here. If it's exterior, it's a slab on grade, it's a slab below grade. Are you really concerned about the little bit of water that might make its way past the waterproof membrane and not go down the drain and actually get into the concrete slab? It's not a big issue. But certainly the membranes can be placed on exterior walls. Again, you check with the manufacturer of your membrane to see what suitable substrates are that you can apply these to. But no, you don't really have a whole lot of stumbling blocks when you're talking about exterior showers.
Great. So going back to cutting a shower tray down, where do you suggest you cut it? Low side or high side?
Well, it's where the drain's going to be is going to dictate how much you're going to cut off, right? So you should, you know, you are going to cut the perimeter off, but it's all based on measurements. You measure from the center of the drain out to the walls in all directions, and you transfer those measurements from the center of the drain on the tray out to the perimeter in all directions, and that will dictate how much you take off around the outside. So yeah, you're going to take the outside off because you want to have the slope go the rest of the way in.
So on a linear drain that's at the wall, is that the same answer?
Yeah, you would you would take off the high side. Well, you know, because it's kind of tricky to take off the low side.
Yeah, that's what I thought.
Because when you're doing that, you have to reposition the actual drain body and its flange and the way it ties together, which you can do. I've seen it done. But if you think about it, aren't you always better off taking the high side of the tray off and reducing the overall you know, elevation of the room? Typically, that's where you want to take it off.
All right.
Now, let me add to that, Jim. I'm just thinking, if the recess is too deep and they want to keep the high side because they need to do that, I would still cut the high side off, and then I'd put another layer of concrete masonry unit. I mean, a concrete backer unit. If it's over concrete, I would put in a foam core board, a couple layers and uncoupling membrane to build up that recess a bit. Because if it was poured deeper than you actually need for the tray thickness, I would build the bottom of that up so you could still use the perimeter height.
So everybody knows that this presentation was put on by Schluter, and Andy Acker, he works for Schluter and has answered a lot of our questions. If someone wants to buy a Schluter product real quickly, I'm going to give you a little plug. Can they go to a website? Do you have locations listed on your website?
We do.
Okay.
We have several. They can go to schluter.com and go to our dealer locator, and you can plug in your zip code, and it will give you a list of everywhere that you can get our products, starting from your zip code and how many and what the mileage is away from where you are to get to that. So yes, they can.
Perfect. All right, I got another question here. Since Schluter All Set is a you know, an all-purpose thin set, could it also be used for almost any other water impermeable backer board to adhere porcelain to wall tile? Porcelain wall tile, adhere porcelain wall tile. I'll get that right.
So are they, say that again, Jim. I hope I'm not understanding
So-
that they think that the thin set is waterproof.
Yeah,
No?
that's what I'm wondering. Schluter all set, all right?
Mm-hmm.
They want to know, could it be used for almost any other water impermeable, I'm having a hard time with this, backer board, to adhere porcelain wall tile?
Oh, water impermeable backer board. In
Right.
other words, a backer board that isn't absorbent, like, you know, so many of the
Like a
concrete
cement
backer
board.
units
Yeah.
and the fiber cement ones are not waterproof. They're just
Right.
water resistant, right? They don't. You can get them soaking wet and they won't break down, but they still allow water to pass through. I think what this
Correct.
person is asking about are the water impermeable boards that are on the market. Yeah, certainly you could. You could use that particular type of thin set in those applications. It'll work there too. Yes.
Well, thanks for clearing that up for me. I
Yeah.
had a hard time even reading that one, so no
I
problem.
wouldn't want to say that word more than once, and I.
Yeah. I want to thank you again. Great presentation. Lots of information on curbless showers, right? And I was listening. So good job. I want everyone to know thank you. You guys have been a great audience and good questions. And look forward to our next webinar coming up soon. But thank you, Andy. I appreciate it. Thanks, everybody.
Yeah, thank you, Jim, and thanks everyone.
All right. Bye.
Bye-bye.